Hello everyone. Welcome back to our channel. Today, we are going to unravel one of the most fundamental and powerful concepts in the Spring framework, Spring Dependency Injection. This concept is absolutely crucial for building robust, maintainable, and testable applications in Java. In this 5-minute animated whiteboard tutorial, we will break down what dependency injection is, why it is so important, and how Spring brilliantly implements it using its inversion of control container. We will look at practical code examples and discuss some common pitfalls to avoid. By the end of this session, you will have a solid understanding of how Spring handles your application's dependencies, making your code much cleaner and more modular. So, grab your virtual pen and paper, and let us dive straight into the world of Spring dependency injection. Alright, let us start by understanding what dependency injection actually means. Imagine you are building a complex application, say, an online shopping system. Your order service might need a product repository to fetch product details and a payment gateway to process payments. When one object relies on another object to perform its task, we call that a dependency. Traditionally, you might create these dependencies inside your order service using the new keyword. However, this creates tight coupling, making your order service difficult to test independently and hard to change if, for example, you want to switch from one payment gateway to another. Dependency injection, or DI, is a design pattern where, instead of an object creating its own dependencies, those dependencies are provided to it from an external source. It is like ordering ingredients for a cake instead of growing all of them in your backyard. Spring's inversion of control container is that external source, managing and injecting these dependencies for you. Now, how does Spring achieve this magic? It uses something called the inversion of control, or IOC, container. Think of the IOC container as a smart manager for all the objects, or beans, in your application. Instead of you creating objects and wiring them together manually, you tell Spring what objects you need, and Spring takes care of creating them and injecting them where they are required. This is the inversion part. The control of object creation and life cycle is inverted from your code to the Spring container. Spring uses annotations like @component to mark a class as a Spring managed component and @autowired to tell Spring where to inject a dependency. When your application starts, the Spring container scans for these annotations, creates the necessary objects, and intelligently wires them together based on your declarations. This significantly reduces boilerplate code and promotes a highly modular architecture. Let us put this into practice with a simple Java example. We will create a message service that provides a message and a notification service that uses this message service to send a notification. Notice how the notification service does not create an instance of message service itself. Instead, it declares it as a constructor parameter. The @autowired annotation on the constructor tells Spring to find a suitable message service bean and inject it automatically. When you run this Spring Boot application, the @Spring Boot application annotation kickstarts the Spring container. It scans, finds message service and notification service, creates instances of both, and then injects the message service into the notification service as constructor. Finally, our main method retrieves the notification service from the Spring context and calls its sendNotification method. This demonstrates how Spring seamlessly manages the dependencies without any manual new keyword usage from our side. While dependency injection is incredibly beneficial, it is also easy to fall into some common traps. One frequent mistake is over-reliance on field injection at auto-wired directly on a field for mandatory dependencies. While convenient, it makes your object harder to instantiate outside of the Spring context and hides its dependencies. A best practice is to prefer constructor injection for mandatory dependencies, as it clearly declares what an object needs to function. Another pitfall can be circular dependencies, where object A depends on B and B depends on A. Spring can sometimes handle this, but it often indicates a design flaw. Always strive for a clear, unidirectional dependency flow. Also, remember to design your components to depend on interfaces rather than concrete implementations. This makes your application even more flexible and easier to swap out implementations without changing the dependent code. And that brings us to the end of our 5-minute journey into Spring dependency injection. We started by understanding what dependency injection is and why it is a game changer for writing clean, testable Java applications. We then explored how Spring's inversion of control container manages object creation and dependency wiring using annotations like @component and @autowired. We walked through a practical example demonstrating constructor injection in a Spring Boot application. Finally, we discussed common mistakes to avoid and embraced best practices like constructor injection and relying on interfaces. Remember, dependency injection is all about giving control of dependency management to the framework, leading to loosely coupled and highly maintainable code. Keep practicing these concepts, try building your own small Spring applications, and you will master it in no time. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more Java and Spring programming tutorials. Happy coding, and see you in the next video.